Kobalt Quick Connects. Pretty good idea. They've got a push button here on the top that releases the hose that you've got plugged in. You can put it in with one push, and it clicks twice. And then when you're ready to take your attachment out, your hose, typically you mash the button one time and it pops part of the way out, letting the pressure off the hose, and then you mash it again and pull it all the way out. That way the other quick connects, like these guys, when you pull it loose, when you let out your hose, the hose can go flying everywhere, whipping around, letting the pressure off. So these guys have a two-stage release. The first push button lets off most of the pressure, the second releases it totally. So it's a pretty good idea, and just under $7 a piece or thereabouts at Lowe's. Not a bad buy. There is others out there that start at about $15 and some that go up above $30 that are probably more for OSHA, for everyday use and stuff. The problem I had with these is I used it about 10 times, and on the 10th or so, thereabouts, somewhere around 10, I couldn't get the connector in, and then once I got it in, I couldn't get it out, and I couldn't get the pressure. It was leaking air, and I had all kinds of problems with them. So I tore it apart to see what made it work, and this is what I found inside. Here is a good one. As you see, we've got the housing with the push button, got a rubber gasket in there, got a plastic piece and a spring, and the connector that goes in here, or what you connect to. The problem I found was this plastic piece. If you look real close, you see it's kind of thin and flimsy, and when I took mine apart, this is what I found. For the plastic piece, the top part had broken off. The flimsy part, you can see the remnants of it, if it'll focus on that. Again, this is what it should look like. And this is what mine look like. So I decided to make a replacement out of aluminum. And so far it's done pretty good. I had to do a couple of iterations to get it right, to get enough flow through it. Didn't have to round this off to go into the spring, but I had to make that the right size for the spring. So this seems to work. We'll give it a shot and see if it lasts more than 10 times, more than that guy. We'll see what happens. Here's another view of how it kind of goes together in there. You can see my aluminum piece in there taking the place of the plastic piece. If you take that end loose, this end, you're going to have little ball bearings that fall out, so you got to be careful if you do that. But you can recover from it as long as you don't lose any little ball bearings. And you don't really need to take it apart from that end, because the problem is typically in this end. If you're interested in the machining, I started out by drawing this, I call it a valve, air valve, connector valve. I drew it out on paper first, but I made modification after modification, so I decided to go ahead and put it into Fusion 360 because I wanted to learn that anyway. So this is one sheet of two sheets for creating the valve. The second sheet is mainly the milling operation. But I start out with 5/8 inch stock and put it into a collet chuck with a stick out of about 2 inches. And then I turn down what I call the front side to the 370 thousandths and drill a hole, and then turn the back side down to the 2 dimensions. The last dimension is a 1/2 inch here, is used mainly just to hold it in the collet chuck later, and it's set to 0.3125 diameter to fit the chuck, and it's sawed off later. But it starts out on the lathe, turn it down, and I end up with something like this. Hole in the end of it, 5/8 diameter, and of course the 1/2 inch of for the diameter of the chuck that it'll be going to on the mill. Like I said before, I turned the back end down, the 1/2 inch on the other side, to, I guess it's a 5/16 diameter for this collet, and I put it in a hex collet set so that I can cut 3 sides, cut the 3 slots along the top here, and I use 1.25" slitting saw that is about 0.065 thick, so I do 2 cuts in this, do 2 cuts to get the full dimension of the slot. Then to do this part, I use a 1/2 inch end mill, and also instead of the hex collet holder, I've got a square collet holder that I use to put the 4 slots in that side. And here is the milling paper drawing from Fusion 360. I used Fusion 360 and created it in the 3D model, as you see down here, a typical picture of it, and then moved it over and created the drawing so that I could use it. This has been a learning experience for me. I've enjoyed it. And again, if you aren't learning, you aren't having fun. Thank you. Goodbye.